done a book review in a while. So tonight's book review will be on Sky Catalog 2000. This is volume 1. It's edited by Alan Hirschfield and Roger Sennett. This is one I was reading during Christmas time. And I happened to pick it up. I've got burn hands, but I was looking for a little bit more, and I found out by reading the front page of this also that I did have there's other ones out there that I don't have. So this one I happened to get a copy of, but this one was put out by Sky Publishing Corporation out of Cambridge, part of Cambridge University Press. There's a lot of good stuff that they put out, and I think Sky and Telescope helped put this out. So it's got over anything from about 0 to an 8th magnitude star, which for amateur astronomy, that's really all you really need is a catalog of this type, because it's not most people are not going to have a telescope, maybe 6 to 8 inch Newtonian refractor or something like that. Any star from up to 8th magnitude is just fine for viewing. You can pick it up, you know. If you got just binoculars or something like that, you know, it's not going to be very effective at getting visualizing some of the stars. But this is geared pretty much for the amateur astronomer, so it's perfect for that purpose. So I've made some notations in this, so I'm going to go through the notations. But it's got all stars down to 8th magnitude, small or medium-sized telescopes. You see galaxies, nebulas, comets, and asteroids against a starry vault. So the main thing you want to use this for is to find the star, and then if you're looking for a nebula or a galaxy or something like that, this is the book you're first going to go to. And then once you got that star, you're pretty close to wherever that galaxy is. So it's a way of navigating out there, and it's not easy. It takes a while. So the best thing to do is go to an astronomy group with amateur astronomers that understand our right ascension and declination, and look through their telescopes, and they show you how they navigate around. And you can also look through see their navigation on their telescope. Some got, spent a little bit of money and they got a laptop they can use, and have gotten pretty high tech, and they just punch it up on the laptop and the scope automatically does that. It depends on how much money they want to spend or they got to spend. So some got some pretty high tech stuff as far as viewing goes. But this one it also talks about the other star guides, which I wasn't even aware of. There are some large star guides for people that are getting to the big telescopes and stuff. But if you live close to an observatory that has one of those, some do have open observations, so it doesn't mean those are totally off limits. And sometimes they have special viewing hours, so there are observational guides that you can use that are more attuned to that you can buy. There's a massive 4-volume Smithsonian Astrophysical Observation Star Catalog with over 250,000 entries, so it's pretty extensive, and it's put out by L.F. Jenkins, General Catalog of Trigonometric Stellar Parallaxes in 1952. So it's probably not going to be in color, but you're talking an extensive network of stars. He's probably put together the entire Hubble gallery. You know, Hubble spent his whole life, you know, just observational astronomy. So he spent a lot of hours out there and cataloging all that. So I mean, there are, you know, what can one man do in one lifetime? Well, if you get that catalog, you can pretty much see what all Hubble was able to catalog out there. It's a lot of kind of tedious, you know, and at times boring, because the amount of time you have to spend at the telescope and stuff and getting all that calibrated and stuff just to do viewing and actually finding your target destination and stuff. So, you know, it takes a lot of, and you can only do it at night, you know, when everybody else is asleep. So, you know, it comes with its good points and its, you know, bad points as far as astronomy goes. Hubble had to get up and, you know, work at all hours of the night to get certain stars and stuff, and then find them, and, you know. Thankfully, somebody like him was able to put that together. There's also another sky catalog it mentions by Scala Nato Calesso Atlas catalog by Anton Bevar. General collection star data has over 6,400 stars down to a magnitude of 6.25. It has references to both amateur and professional astronomers, so it's kind of geared to both. And there's also the Star Atlas catalog, which I've got right here, which was put together by Sky and Telescope and a computer science corporation called SkyMap back in 1978. 78, I was just kind of a kid, and I did get to go to some of the astronomy events where they actually get, you know, you got to see the big telescopes, and had a pretty good museum to, you know, watch. That had access to a pretty good wide range of telescopes. So, you know, back in 1978, there was a lot of observational astronomy going on. And that's what this volume here is a product of. There's also one put out a SkyMap new catalog stellar data, November 1978. That was, okay, volume 38. Has over 248,000 stars. This is only volume 1, so, you know, if you get all the volumes, you're getting a catalog of over 248,000 stars. So, not that you're going to look at all those, but I mean, you're getting a good, pretty broad spectrum of stars out there. So, you know, this is just one volume. If they become available, I'm going to, you know, keep on buying them. Because it's kind of a supplement to Birmingham Celestial Handbook as far as the observational astronomy goes, because you want to be able to find the star first and then find the find the galaxy or nebula or something that's pretty colorful and you want to photograph to go with it. But all the stars in here are listed under right ascension declination, so it gives you the exact right ascension declination is very important as far as being able to observe the star and find it. It also gives you the magnitude. Sirius is the magnitude of 1.46, which is pretty bright. Sirius is very easy to find in the sky. I can always find it because it's one of the brightest stars in the galaxy. It's also one of the largest stars out there. It's fairly known. It also has a satellite that went with it. But just looking at that, you've got a 1.46, and you go down here and you can see Betelgeuse, which is a large red giant. It's 0.50, and also a variable star, so it fluctuates. And if you want to study variable stars, this book's got all the variables listed. have an interest in variable stars because I want to see the fluctuations over the entire galaxy, and trying to figure out when those stars are put out there and how old they are and stuff. So it's kind of helpful. The magnitudes are listed in here, and then it's also color temperature relations. Gives you a surface temperature. Good example of that would be like Betelgeuse is listed about about 35,000 Kelvin, which is still fairly high. And then you got Sirius, which is a lot newer star, is listed at about 12,000 Kelvin. So there's a broad difference between Sirius and Betelgeuse. Also got spectral types. There has been some advances in spectrometry since 1978, but they're constantly updating this stuff, so don't think this is used. I got this at a used bookstore, but I mean, don't think that it's totally up to date. There's stuff that spectrometers that they're picking up nowadays that they've got nowadays that are give you a lot more information as far as stars go and stuff. But the spectrometers that are listed on here that they were used give you the apparent color, the spectral type, and when you got the reason why you want to know the spectral type of the star, because you don't want to know what its composition is. Like a spectral type 0, you get strong lines of ionized helium, ionized metals, hydrogen. So if you see in the catalog it's a spectral type 0 O star, then that's what it's mostly composed of. There's also spectral B star, lines of neutral helium, prominent hydrogen lines, stronger than type O. So it's also a blue star. All the blue stars are very new stars. You got a spectral type A star, strong lines of hydrogen, ionized calcium and other ionized metals, weak helium lines. And then you got a apparent white star, hydrogen lines weaker than type, ionized calcium, strong lines of neutral metals becoming prominent. So you got a white star, that's spectral F. And then you got a G, numerous strong lines of ionized calcium, other ionized and neutral hydrogen lines weaker than type F. And then you got the spectral K, which is a orange star, which is what I think our sun is. It's got strong lines of neutral metals. Actually, I think our star is a white to yellow. It borderlines on it. I think it's a yellow dwarf, if I remember right. So it's not our star seems fairly big, but it's actually very small compared to the rest of the galaxy. It's not a real big. I think it's classified as a yellow orange dwarf. So it may seem big to us here on the planet Earth. It's actually, as far as the galaxy goes, it's not that big of a deal. I made some notes in here. It's how they calculate distance out there. I don't treat that biblical because it's just there's different measuring that kind of distance and stuff. It's just I have my doubts of how accurate that is. So you have to go by what they put in there, but don't treat it as being biblical or anything because it may not be that accurate. You know, I don't. It's hard to say. It's just like dating goes and stuff. You know, 'cause we got carbon-14 dating and stuff. It's questionable how accurate that is, but it tells you in here the trigonometry parallax is normally expressed in seconds of arc and equals the maximum angle at which a star strays in the course of a year from its central or average parent position. So they're just actually measuring the wobble and stuff, you know. But that's not really, it's not true distance. It's not like when we went to the moon, we put a laser and a dish, some kind of mirror out there. So we got an exact reading from the planet Earth to the moon. So we know exactly in 1963 or 64 how far the Earth was from the moon. And it is moving a little bit. It's like an inch or half a year. So the moon does stray. But it, you know, that is accurate. But I mean, when you're measuring light years distance and stuff, you don't have the ability to do that. So how accurate is it? You know, 200 years from now, we may find it was fairly accurate, may not find it was not very accurate at all. You know, so, but anything like what that from here to the distance to the moon, you know, is very accurate because we're able to get a feedback from it. From here to like Jupiter and stuff, and Mercury or Venus, we do have radars that we can bounce out there, and I think they can get a feedback from that. So, you know, you can get fairly good distance readings on that, which with really good accuracy. But anything out of the solar system and stuff, you know, 200 years from now, you know, it may be accurate, it may or not, may have fairly been accurate, or it may not have been accurate at all, you know. Parallax is measured by, let's see, Alpha Centauri has a parallax of only about 0.75, which is the parent size of a postage stamp at the distance of nearly 7 kilometers. And trigonometric distance in this catalog is indicated by the letter T. So you're getting the calculations as to how far they think it is. Gives I made a notation here. A further complication with the spectrometrical derived distance arises from the dimming of light by interstellar dust particles along the line of sight. So you're also having to, you know, I've mentioned that several times. That's even mentioned in the book. But from here to the nearest star, you know, you're not getting, there's a lot of dust and debris between you and that star, and it's giving you false feedback. You know, it's just like me cleaning my glasses right now. You know, it inhibits our ability to judge distance. So what's going to change that is to be able to travel out there in space. Then we'll know what the truth is about how far the distance is. It's like when we got in the ships and we started traveling on the ocean and stuff. And at the first years, we didn't know what we were doing. But eventually, we finally were able to navigate the whole planet and know the exact mileage and the distance of the stuff. And it took time, but we got an accurate reading, and you can go anywhere in the world now with the GPS device and find anything, you know. But that took time to be able to judge the distance between certain places. It took time and a lot of data gathering, you know. It's more than what one person can do in one lifetime. You know, it took several generations of people going back 300 years ago of traveling. And just now we got GPS, so we got an advantage over people back in the 60s who are trying to navigate around out there having to just use a compass, you know, and stars. So technology is changing. motion in space. That's been covered by a lot of YouTube sites about what they get from that. So I'm not going to get into that. It's really not going to help much. But gives you a constellation of abbreviations and common names of stars in there, and it gives you a designation to each of the stars, you know, and they're listed like this. So you're not getting color pictures or anything, but you're just getting pretty good raw data. So this is a data book. You know, it's not like Burnham's, it's going to give you pictures of the stars and the galaxies, but what the big telescope's up there, but it's going to give you good raw data. Here's the column headings. Each one of these columns that goes across here, you get the star type over here, and then you go across there, and everything in between is data, just raw data. So, you know, it's got lots of good data in there. It gives you the stars number, which would be the first one. It gives you the astrobit. It's SOA in the Smithsonian Astronomical Observatory Star Count, which is one of the big ones. I don't have that one yet, and I've only got one volume here. It also gives you the star name, gives you the right ascension, the declination, so you can find it, the proper motion in right ascension, proper motion and declination. So those first four right there are going to get you on your navigation to find that out. Now, you go to some of the astronomy clubs and you'll see somebody's got some fancy navigation. All they do is punch those numbers in and bingo, it goes right into the, you know, you can find it in less than 25 seconds. So, you know, it makes it very easy. It gives you the magnitude, the star's visual magnitude, whether it's a yellow star, orange, its color index. Gives you the absolute visual magnitude, the star spectral type, which is pretty important because that's the only real raw information you're going to get on a star. It's going to tell you what that star is composed of. So besides getting a visual of it in a telescope, you're also going to get information as to what the composition of that star is. So you're getting some good raw data. Radial velocity, distance of the star in parsecs. The star's number and Atkins' new general catalog of double stars. I don't have that one either, but if you got that one, you got references in this book too, so you got a kind of companion guide to it. So you're getting a lot of good raw data in this catalog, you know. It's not like Burnham's, doesn't have any color pictures in it, but you're getting good raw data, you know. And there's actually 28 volumes, and this is just volume 1, so, you know, look at the what you're getting just out of volume 1. So I'm continuing to purchase stuff like this. I plan on getting the. I used to have a 6-inch Newtonian I used to use, but it didn't survive the moves that I made, so it's no longer really operational anymore. So, you know. I'm planning on eventually having at least an 8-inch Newtonian or a refractor or something, you know, something around 8 inches. That's all you really need for amateur observation. And if you're going to photograph, there are a lot of good stars, observational astronomy sites on the YouTube. Google. And also, there's also amateur photographers. Most people, a lot of observational astronomy nowadays is mostly just amateur photography, you know. Besides, you know, observing, you're also taking pictures. It takes a little time, you know, you're going to have a couple of hours of sitting there and, you know, twiddling your thumbs because you get a good photograph. sell them, you know. I've seen them at fairs and stuff. I've seen some photography people selling those pictures out there. So, you know, some people want a picture of Andromeda or, you know, or Sirius or, you know, whatever. So, no, that does that for this one.